All right. 2, 4 complex numbers. We're going to be writing units in I to write complex numbers. I guess we're going to use imaginary units. We're going to add, subtract, multiply them. We're going to use complex conjugates to write the quotients. And we're going to find complex solutions to quadratic equations. So if you remember that the square root of -1 is what I represents, because when we go to solve some of these quadratic equations, we get a negative exponent underneath the square root, and we can't have negatives underneath a negative number underneath the square root, and we can't have a negative number. So first of all, what we're going to do is we're going to write things. The standard form of a complex number is a plus bi, where a is the real part, b is the imaginary part. So for example, in example 1, we're going to write -5 plus the square root of -9. Well, this is the real part. This is our a. We know that a square root of a -9 does not exist, so that's imaginary. But what we can do is, well, that's going to be 9, square root of 9 times the square root of -1. Well, what is the square root of 9? 3, and then square root -1 we write as I. So pull out that, get rid of that negative by putting an I out there, and then simplify your square root. Pretty easy. It's a square root of a -1. Because -9 is 9 times -1. I squared does equal -1. All right, you guys can read all that stuff. Let's look at example 2. So when we add or subtract, what we do is we add or subtract the real parts, then we add or subtract the imaginary parts. I think of I as like an x. If it was 3x plus a -4x, it's -x. So if it's 3i plus -4i, it's just -i. So we add 7 and 5 and get what? 12, and then just 12 minus I. B, I'm going to do these two first. So 5 plus 3 is 8. -I plus 4i, 3i. We need to subtract 8 plus 3i. It's 0. 8 minus 8, 0. 3 minus 3i, 0. Questions are adding or subtracting. I think everyone should get all of those right. You are pre-calc students. You know how to add and subtract. Multiplication of complex numbers. Well, if I to the first is just I. Well, I squared means I times I. Well, I is the negative square root. So is the square root of -1 times square root -1, which is what? -1. I cubed is I times I squared, right? So I squared is negative 1 times I gives us negative I. I to the fourth, well, that's I squared times I squared. I squared is negative 1 times negative 1 is 1. And what happens in the next line? It's a pattern. It repeats. This is I to the fourth times I. Well, I to the fourth is 1. That's I. This is I to the fourth times I squared. I to the fourth is 1. I squared is negative 1. I to the fourth times I to the third. I to the third is negative I. I4 times I4 is 1. And then I to the ninth will be I to the 10th, I to the 11th, I to the 12th. The pattern just keeps repeating. What's that? I said this is the same as I to the 9th, I10, I11, I12, and then 13, 14. They just keep repeating. Questions? Okay, so let's do some multiplying. You guys can distribute this out. 3 times 5, 3 times 4, 4i, negative I times 5, negative 5i, negative I times 4 is negative 4i squared.
You said 3 times 4 is 4.
Yeah. It's 12.
It's 12. I don't know. Thank you. Combine these. 7i. And then what is I squared? Negative 1. So negative 1 times 4, negative 4 is positive 4. So 19 plus 7i. Okay, how do we do 5 minus 3i quantity squared? This is, yeah, 5 minus 3i times 5 minus 3i. 5 times 5. 5 times negative 3i. Negative 3i times 5. And then there's 9i squared. (15 plus 15 is 30, so negative 30i. Remember, I squared is negative 1, so 9 times negative 1, negative 9, so 16 minus 30i. Questions on multiplying them? Complex conjugates. If you multiply a plus bi and a minus bi, the product is a real number. Well, how does that work? Well, a plus bi times a minus bi. This represents two complex numbers. They're conjugates. What's the conjugate? It's the same binomial, but the signs are changed. Okay? So a squared minus abi plus abi minus b squared I squared. Well, what happens to to the middle terms here. They cancel out. So we have a squared minus b squared. Well, I squared is -1. So when we take and multiply the complex number, and its conjugate, we're going to be left with a squared plus b squared. Okay? So, why, when we look at fractions, why can't I leave this quotient as 2 plus I over 2 minus I? Because this I is like having a square root in the denominator. To get rid of that, what do we multiply top and bottom by? The conjugate of the bottom. So if this is 2 minus I, we're going to multiply by 2 plus I. Now, we just talked about the bottom. It becomes a squared plus b squared. What's your b value for this denominator? 1. So this is going to be 2 squared plus 1 squared. The top does not work that way because this is a plus and this is a plus. We've got to multiply it out. 2 times 2 is 4. 2i. Distribute the I, there's another 2i plus I squared. So this is 4 plus 2i plus 2i, 4i, I squared, -1. This is all over 4 plus 1. So we have 5 on the bottom and 3 plus 4i on the top. If we want to write it in true complex form, we have to do this.
Where did the 1 come from?
This one,
Yeah. No, the one bottom. Yeah.
what number's in front of I? If it was 2 minus 3i, your b would be 3. But there's an implied 1 here.
Should it be 3 fifths plus 4 since I?
Should it be what?
Subtracting. Like,
At the bottom?
very bottom, like 3 fifths minus 4 fifths I. Should that be plus?
Plus, yes, thank you.
Why is it not negative? The 1. If one of them is negative.
It's minus b squared, but the I squared is negative, so it changes the sign. Okay. It is true if we did a minus b times a plus b, where it wasn't complex, it was a squared minus b squared, but this is not a complex number. This is like x minus 3 and x plus 3. Okay? All right. Principal square roots of a negative number. If a is a positive number, the principal square root of a negative number a is defined as. So the square root of a negative a is I times a. Now when we go to multiply these out, we need to be careful here. We will need to write them as complex numbers first. Don't apply the square root rules. So if I write this as a complex number, what is it? Isn't that I times the square root of 14? I like to put my I in front so it doesn't accidentally slip underneath the square root. And then the square root of -2 is I times the square root of 2. Now, multiply these two. What's I times I? I squared. Now I can take the square root of 14 times the square root of 2 and get 28. I squared is negative 1. 28 is 4 times 7. So this is a negative 2 square root of 7. Questions on A? B, why don't you try B? So this one was I times 9 times 3. So 3I times square root of 3. Minus, well, that's I. 12 is 4 times 3. So that'll be minus 2I square root 3. And can you now subtract these? Yeah, what's 3I? Take away 2I. I square root 3. Questions on that one? Okay, C. It's going to be negative 2 plus I times square root 5 times negative 2 plus I square root 5. Again, when you're multiplying and you see those negatives underneath the square roots, write them as negative, as I complex numbers first. Write them as an I. Now you can multiply. Distribute the negative 2 through. Then distribute the I square root 5 through. It's going to be I squared times 5. I times I squared, square root 5 times square root 5 is 5. Negative 2I minus 2I is negative 4I. I squared is negative 1. Negative 1 times 5, negative 5. And you can now do 4 minus 5. Questions? right here. Is that what you're talking about right here? Other questions? All right, let's look at this last one on this page. How do we now can solve x squared plus 9 equals 5. What do we do? Subtract 9. Square root both sides. Square root of 9 is 3. Questions on 6? Are you done? Then we get one more problem, which is that using the quadratic formula.
Love that.
Here we go. Gave us lots of room. This doesn't factor. And so we need to state A, B, and C. What's A? What's B? What's C? Quadratic formula, negative B plus or minus B squared minus 4AC, all that divided by 2A. All right, are we ready? Okay, x equals negative b. Well, b is 14, so it's going to be a negative 14. Plus or minus. What's 14 squared? 196. Minus 4 times a times c. All over 2 times a. So 196 minus, what's 4 times 8 times 9? 288. All over 16. But what's 196 minus 288? Negative 92. Can we just simplify that 16 and that 4, or that 14 and that 16, or that 92? Can we divide those all by 2? Please tell me no. Thank you. The only time I can simplify is if all three of these and what's outside, these two and what's outside the square root is divisible by the same number. Some people will divide them. Some people will just simplify here. It has to be all three. But 92 can be simplified. That's 4 times 23. So then the square root of 4 is now 2i square root 23 divided by 16. And now all three of them are divisible by 2. So negative 7 plus or minus I square root 23 all over 8.